Welcome to another incredible edition of Comet Algebra. This video is for Algebra 1, Chapter 7, Section 4, Solving Systems by Elimination. So far in this chapter we've learned how to solve systems by graphing them to find the solution where the two lines cross each other. We learned one algebra method called substitution, and now we're going to learn a second algebra method called elimination. And I think after you've tried both of these, you will develop a liking towards one of them. Everybody seems to have their preference, and it's always interesting for me to hear what your preference is. So elimination is also known as the addition method. And of course, it's an algebra method used to solve for both x and y. So I'll explain it that you need to make any adjustments necessary so that when you do add the two equations to each other, one variable is eliminated. Or another way to say that is when you add the two variables, they add to 0. And if one is eliminated, then we're left with one equation with one variable, and we can solve that. So we go ahead and solve it, and then of course we take that answer just like we did with substitution. We plug it back into one of the original equations and solve for the other variable. And of course, check your answers. So hopefully that made a little sense, but if not, we'll clarify it here with an example. The directions say solve by elimination. Now remember, I called this up here, we called it the addition method. So the goal is that we're going to line these up like I have already lined them up for you, where these x's line up with one another and the y's, and the equal sign lines up and the answer. So that when we draw a line here, and when we add these like terms and add these equations, one of the variables, like I said right here, adds up to 0 and it's gone. That's why it's called elimination. So planning ahead, I'm looking at this, and this is set up very nicely for elimination. Because right here we have a positive y, and here we have a negative y. And I'm planning ahead, and I realize that those are going to add to 0. So in this particular example, no adjustments are needed. That's nice. Let's just go ahead and add straight down. 2x plus 1x is 3x. Positive 1y and negative 1y add to 0. I'm not going to write the 0 there because it's not needed. And adding straight down, negative 5 plus negative 7 is negative 12. Now this is a nice short equation to solve. You simply need to divide both sides by 3, and you have x is equal to negative 4. That's one of the answers. And just like in substitution, you go back to the originals and plug it into either one of them to find the other variable. I don't know, I guess I'm just going to plug it into the first one. So I have 2 times negative 4 plus y equals negative 5. Go ahead and multiply. We've got negative 8. So then if we add an 8 to both sides, I end up with y equals 3. So those are my two answers. And once again, you can write that as an ordered pair if you like. All right, looking at example 2, we're asked again to use elimination to solve this. And I'm doing a little planning ahead. I'm going to write it out, but normally I'm just thinking this mentally. So if I try adding these right now, I get 4x and I get 7y, and neither one of them added to 0, so this isn't working right now. I'll try to erase that. So we need to do some adjustments. Clearly, some changes are needed to make this work. So when you're planning ahead, look at your coefficients. These x's both have a coefficient of 2. So that looks like it might be an easy adjustment to make. So I'm imagining if one of these is negative, then when I go to the adding part, this is going to add to 0. And in this case, we have a choice. We could multiply this top equation by a negative 1 or the bottom equation by a negative 1, and it doesn't matter. It's your choice. So I think this time I'm going to go ahead and multiply this bottom equation by negative 1. So I'm going to leave the top equation alone, because in my planning ahead, I'm going to get rid of the x's. Now, be careful here. When you multiply an equation by a value, you have to multiply everything in the equation. You're distributing this -1 to every part of the equation. So 2x times -1 is -2x. 3y times -1 is -3y. Keep your equal sign. And -1 times +1 is -1. So now if I have planned ahead correctly, when I add these, one of the variables should add to 0. And indeed that happens. 2x minus 2x is 0. Wow, this worked out really great. 4y minus 3y is just 1y. And -2 plus -1 is -3. So we're done. We have the y value. So let's go back to one of the originals. Again, it doesn't matter which one. And let's plug in the -3. So if I happen to choose the first equation to put the -3 in for the y, so I get 2x minus 12 equals -2. Whoops, I put two negative signs there, sorry. I want to add a 12 to both sides. So I get 2x equals 10 and divide both sides by 2 to get x is 5. So my solutions are 5, -3. So as we go through these examples, the adjustments may be getting a little more challenging so we can learn how to make them. So once again, we're going to use elimination and we need to plan ahead. So if I look at these x's, well, one thing I noticed that's nice, one is positive and one is negative. But in order for the x's to go away, I would have to end up with a 12x here and a -12x here, and that requires adjustments on both equations. And that would be fine, but let's just investigate the y here. Again, what's nice is we have a plus and a minus, so we don't have to worry about that. And here we have a 2y, and it wouldn't be very difficult to get a 2 here. I would only need to make one adjustment by multiplying this bottom equation by 2. So once again, the top equation just stays the same. And then we go ahead and multiply every single piece of this bottom equation by 2. So then I'd have a -8x minus 2y equals -70. Now you can see this one would be a little harder to graph with the 30 and the 35. So the algebra methods are very useful. So now if I have planned ahead correctly, when I add these two, the y should disappear. 3x minus 8x is -5x, and indeed 2y minus 2y is 0, and then 30 and -70 is -40. Divide both sides by -5, and x is +8. And of course, plug it back into one of the originals. I'll just choose the first one. That's 24, so subtracting a 24 from both sides gives me 2y equals 6, and dividing both sides by 2 gives me y equals 3. So this system has the answer of 8 and 3. All right, this last example is a little more challenging. As we investigate the possible ways to make the elimination happen, I look at the x's, and the common multiple for 5 and 6 would be 30, so I'd have to have a 30x and a 30x, and one of them would have to be negative. Planning ahead and investigating the y's, a common multiple for 4 and 5 would be 20, so I could have a 20y and a 20y, and one of those y's would have to be negative. So you can choose to make either adjustment you'd like, but either way, there's a little more math involved here. So I guess for no reason, I'm just going to choose to go after the x's. So I'm going to multiply this top one by -6 and this bottom by a +5, and then I'm going to end up with a negative 30 here for the top x, and then a positive 30 for the bottom. So my planning ahead is working, but the math is a little harder. So let's multiply everything by negative 6. And I get negative 30x plus 24y equals 138. And now multiplying everything in the bottom equation by 5 gives me 30x minus 25y equals a negative 140. So now we draw our line and add straight down, and the x's are gone, which is what we wanted to have happen. Positive 24, negative 25 is a negative 1. So I have a negative 1y equals, and this would be, just a negative 2. Divide both sides by negative 1, and we get our first answer of y is 2. And then, of course, plug it back in to one of the equations. I chose the first one, and then solving for x here, I get 5x equals a negative 15. So x is equal to a negative 3. And we have both solutions. So now you have the knowledge you need for 7.4. Have fun with elimination.